Hello all, welcome to the next topic from units and dimensions. So write out the heading which is called error analysis. This is the next topic after significant figures. Error analysis. Error analysis. Listen carefully. What is called error? Suppose I measured some quantity. Okay, I can measure some quantity either x or yz. Suppose I measured some quantity and whose actual value, the real value is, for example, let me take an example. For example, I measured, I know this is 1 kilogram salt is present in this box, for example. Then I measured with a weighing machine. I got 1.01 with one machine. Another machines I got to 0.99. Then I will say like the one machines will have a 0.01 error is higher, for another machine 0.1 of value of error which is lesser. So 1 kilogram is actual value. 1.01 means there are error will be there, 0.01 error will be there. So error means it is a difference between the actual value. Actual value is also called a true value in physics. So it's an error, it is a difference between the actual value and the true value. That is called a error. So we all human beings, and we will measure with the help of some instrument, any physical quantity we will measure. When you are going to your schools, labs and all, you will also going to measure voltage, current. So that is, we cannot say it's 100% correct. It is either little high or little less. That high value or the less value, it is called error. So error is something we are introduced because of the using measurement, because of the using measurmental devices. Okay, so error is not the actual value, it is always creating the difference between the actual value and the measured value. That is called error. So write down the definition. It is the difference between, between actual value is also called a true value. It's a difference between actual value, true value, and the measured value. So that is called, actually it is called a error. So this is a definition of error. Okay, next, in physics, in this chapter we learned about different types of errors. So write on the next heading, types of error. We are going to learn different types of error. Number one, first error is called absolute error. It's called absolute error. Okay, I'll tell you what is called absolute error. Let me take one item, one quantity. Okay, the previous example we talk about something called we talk about salt. Okay, so now I have salt. I measured the salt with a different equipment, different devices, measured the weight of the salt. Actual weight is 1 kilogram, but I don't know that. I am measuring with the different devices. So I have some different measured value. So write down the measured value of a quantity, of an item. We can say measured value of an item are, there are values x1, x2, x3, etc. to xn. These are the different measured value. I measured with one instrument, I got x1. I measured with another instrument, I got x2. I measured with another instrument, I got x3. So all these things are the measured value of an item. Before going to absolute error, we want to understand one quantity, one item, which is called mean value. So write down the heading, subheading, mean value. This will comes under absolute error, so I am putting a suffix called a. So mean value is the average of measured values. How we will find the average value? To find out the average value, this mean value, average value is called x. In some reference textbook, it is given as x bar, but I'm taking it x. So average, how we will find average? We will add all the numbers and divide it by its number. So how we are going to find out the average of all this measured value, x1 plus x2 plus x3 plus etc. to xn, whole divided by how many number of terms will be there? N number of terms will be there. This is called a mean value of the measured quantities. The numerator x1, x2, x3 up to etc. to xn are called different measured values of an item, and that whole adding the sum whole together divided by n in the denominator, then this is called a mean value. We'll go to absolute error. So absolute error, the definition of absolute error we are going to define. So absolute error is the difference between it's quite simple, difference between the measured value is the difference between the measured value and the mean value Okay, so we have a different measured values are there, right? x1, x2, x3, and we have only one mean value. So always it's a difference between the measured value and the mean value. So we will take an examples. Okay, continuation I'm writing here. So the mean value, so this is given as delta x1. Difference means delta x1. You can first I'm taking x. Okay, so x is the mean value, difference between. Okay, you can maybe change this sentence. First you can write mean value in order to avoid confusions. Which one will come first? So in the sentence also mean value is coming first, and the measured value. Then there is no confusions. It's a difference between mean value and measured value. So mean value will come first. Mean value minus measured value. What is the first measured value? X1. That's what we have given, delta x1. Similarly, you have delta x2. What is delta x2? Mean value minus next measured value. What is next measured value? X2, and so on. Finally, we got delta xn equal to mean value minus nth measured value. Okay, and this is called absolute errors. Next, the question is, if somebody will ask you to find out absolute errors, what you want to do? This delta x1, delta x2, delta xn is called absolute error. To get absolute error, first you need to get what is this x is called? X is called mean value. So first your aim is you will given a set of values x1, x2, like for example x is 4, x1 is 4.1, x3 is maybe 3.9. so you will get a different values. So all values you will add, and with its number, how many number of terms are there, you will divide, you will get mean value. And to find out absolute error, x minus mean value minus individual measured values. Once you do this one, this delta x1, delta x2, delta x3, all these terms together is called absolute errors. These are the absolute errors. So never confuse, quite simple. Absolute error means the difference between the mean value and the measured value. That is called absolute error. Okay, hope this point is clear to you. So types of error, first one, it's called absolute error. We'll move to the next type of error. So second types of error, let me keep it here. So you can pause the video and you can complete your notes. First, always you listen while I'm writing. You don't want to write because it's a video recordings. So you have enough time to write a very neat note. Okay, so we'll move to the second types of error. Second types of error is called mean absolute error. Mean absolute error. First one is absolute error. Second one is mean absolute error. So now we have absolute error values are there, right? Absolute error values. You have absolute error values. What are your absolute error values? Delta x1, comma, delta x2, comma, up to etc. to delta xn. Now how to find the mean? Mean means always average. Whenever mean is coming, it is called average. So mean absolute error. I'm putting AE just for easy understandability. So mean absolute error is equal to delta x1 plus delta x2 plus etc. to delta xn whole divided by what we'll do, number, to find out the average value. This is called the number. So this value is called, this parameter, this value is called mean absolute error. Okay, and this mean absolute error whole together I'm writing as delta x. So mean absolute error is called delta x. Maybe you can put it in the bracket called delta x. So how to find out delta x? Average of all the absolute errors. So absolute errors in the mean. So name itself is easy. Okay, first we have to find absolute error, then we have to find a mean. Then you will get something called mean absolute error. We'll go to the third one. Third one is called relative error. Relative error. This will have another name, is also called fractional error. Fractional error. Relative error, or this is also called fractional error. What is fractional error or relative error? I'm putting relative error or fractional error in a short form. Okay, this is not an officially accepted short form. This is for our easy writing. We are using relative error and fractional error. Is equal to mean absolute error is equal to mean absolute error whole divided by mean value. This is the meaning of this one. So what is a mean absolute error, which means delta x? What is a mean value? First we have learned under types 1, it's called x. So this delta x by x is called relative error or fractional error. Okay, first we have learned, then from that second one is coming. Once we learn first two, then third one is coming from first two. Okay, delta x divided by x, mean absolute error divided by mean value. And the last one, it's called percentage error. Is called percentage error. This is the fifth one, percentage error. Percentage error is equal to relative error into 100. Relative error, or it is also called fractional error. So how we can write relative error? We know delta x divided by x into 100. To convert any quantities into percentage, what we will do, we will always multiply with 100. Okay, this is a common principle in physics. If you want some quantity to get in percentage value, you are saying like a tenth I have 96% mark or 80% mark. So percentage we are saying in terms of out of 100 how much you scored. That is the internal meaning of percentage. So if you get some value, you have to multiply it with 100, then you can say 80%, 30%, 40%. What you are getting, that is called in terms of percentage. So 4 types of errors we have learned: absolute error, mean absolute error, and relative error. This is also called fractional errors, and the last one is called the percentage errors. Okay, next we are going to learn about various systems. I mean various system in the sense propagation of errors. Okay, this error, if you have measuring from one quantity and that error is propagated from one system to another system, how it is happening. So we know different types of error. We'll move to the next topic under this error analysis. So 4 types of error. Each 4 types will have a 4 set of equations are there. So this you have to remember definitely. Okay. So next heading, the next heading, it's called propagation of error. Propagation of error. How errors are propagating. Okay, there are 2 things will be there. Under this one, propagation of errors, we have 2 things will be there. For example, addition and subtraction. You can write this heading. I will tell you what it is. Addition and subtraction. Addition and subtraction. Okay, how normally we are representing an error. For example, I measured one quantity, 1 plus or minus 0.1. We will put it like this one. This is a representation of the value. So here, this is, I can call it as a true value, okay, or actual value, and this I can call it as a error value. Okay, so this measurement is contains this much value. The meaning of this one means we have 2 options are there. Either the value is 1 plus 0.1, then you will get 1.1. Either its value is 1 minus 0.1, then you will get 0.9. Okay, so while we are measuring the system, we will either get 1.1 or we will get 0.9. So in both cases, how much error is present? This is less than 0.1. This is greater than 0.1 with respect to 1. So in that case, error value is 0.1. So normally we are representing the error in this condition. Next one, subtraction and addition cases. For example, if you have two quantity A comma B, so A contains some errors, B contains some errors. So if I do one mathematical calculation, x is equal to A and B. A and B are two quantities. A and B are two quantities. I am doing some mathematical operation. X is equal to A plus B. So A will contain some errors, right? I can say A plus delta A. The error contains in A is delta A. So how we can represent B with error B plus or minus delta B. So the error contains in B is delta B, error contains in A is delta A. So A plus or A can represent true value plus error value, true value plus error value for B also. Next, x is equal to A plus B. If x is equal to A plus B means, if I want to find out delta x, this is for true value. I am adding A true value plus B true value. I will get x true value. If I want to get x error, then how should I will do? Delta A plus delta B. Okay, delta. Now, if you are asking me what is the value of A in terms of error value, so x is the original value or the true value plus or minus delta x. Okay, so what is the meaning of this one? I have two quantities A and B are there. These are the two physical quantities. I measured, you can say maybe if it is a rectangle, I measured the length. Length is called A, breadth is called B. Okay, so length measurement will have some error. What is that error? Delta A. So how we can represent the length? A plus delta A. B is called the breadth of the rectangle. How we can represent it with error value? So B plus delta B. Now, if you are asking me, can you tell me what is the length plus breadth value? Somebody come and ask me what is the length plus breadth value. I am saying length plus breadth value is x plus delta x. Then you can ask me what is x? X is the addition of length plus breadth. What is delta x? Delta x is the error available in length plus error available in breadth. So the total length plus breadth value can be represented as x plus or minus delta x, which means true value plus error value. Okay, this is a representation. This is something called a propagation. Why it is called a propagation? Propagation means moving from one place to another, or it is going ahead. Here delta A is introduced an error. Delta B is also introduced an error. So while we are doing some other mathematical operation, for example, length plus breadth in this case, we are doing an additional operation. That additional operations will enhances the error. Enhances the error means the value, the delta x contain the error from A and delta x contain the error from B, and both will get added up here and come to delta x. So the error happened in the measurement of delta A is propagated to the final result. Error present in the measurement of breadth delta B is also propagated into the final result delta x. So the errors are propagating from one stage to the final stage. That is called propagation of errors. So we have A plus delta A and A plus delta B. In the final x plus delta x result, as I told before, the errors which are propagated into the final result. Delta A contains an error. Delta A is an error. Delta B is an error. While I am writing the length plus breadth value delta x, the A value and the B value both errors are adding and coming into delta x. Okay, that is called propagation of error. Propagation means errors are moving from one place to another. What is the physical significance of this one? Okay, this will have a large impact will be there. Okay, for example, let me tell you a practical example. Suppose you are going to, in an engineering level, you are going to design a ship. Okay, suppose you are assuming you are a marine engineer and you are working on the ship design department. Suppose you are designing a ship. Okay, so there you want to take various measurement. Okay, ship in the length, ship in the breadth, driver position is to come where, and passengers has to sit where, and what is the breadth of one seat, what is the height of one seat, and so many measurement value you have to taken for designing the complete ship. Okay, suppose the different engineers are doing this different work. Maybe one set of engineers are doing the design of all the seat into passengers are need to be sit, another engineers are doing for the cot or the bed in which all the passengers needs to sleep. Okay, and other set of people are doing maybe the kitchen designs. So all different types of engineers are working on a different area. Suppose one set of engineers design the seats in such a way that the exact length, exact breadth, I can say length or breadth, the actually the width, in short it's a width. Suppose I'm saying the width of the seat is maybe we'll say like it's 0.2 meter or 0.3 meter, for example. So instead of 0.3, one engineer is introduced a small error which is called 0.32. One engineer is introduced an error in the design of the ship seat. One designer is introduced an error 0.32. So 1.32 means 0.2 meter extra space taken by one seat. In a ship contains how many such seats will be there? Maybe some 500 or 400 or some even for thousands of seats are available. So each designer is introduced a small errors. Means after designing the seats are going to production phase. And at the end of the seat production area, seat company area, the company will produce, okay, company will look into the measurement, company will produce the seat. So thousands of seats are coming and placing it here. The ship design is expected to have 1000 is a seat capacity, but everybody the 1000 is the seat capacity in the sense every seat will have some 0.3 meter width, but actually what is coming from the outside, it is 0.32. So 0.02 meter space extra taken by each chair or each seat. In this case, if I want to occupy 1000 seat, because of this error method, what I will get, maybe I can occupy 800 seats. So 200 seats are wasted because every seat is adding an extra space. If such problems are coming, which means the error which are introduced with respect to one engineer, the error is a minor one. But if everybody is doing like that, then the whole system is getting affected. Okay, that is a big challenges in the engineering design also. If you have making one small mistake, for you it is a small, for you it's a small because you will think in a small box, but when it comes to a bigger picture like a ship kind of pictures, there if you have a sitting capacity of 1000 is available, but because of your bad design it will be ended up with 800 seat capacity. So what is the loss? Finally what is the loss? We lost 200 seats, we lost. So we can say it's a bad designs. So this is a problem. So while we are designing, we should make sure that it's a more accurate value always we are trying to give. If it is a minor error value, okay, then the error will get propagated to the next level, propagate. Finally it will be accumulated and it will have a big impact. That is happening for delta x will be here. Delta x will have an impact of A, delta x will have an impact of delta B also. Okay, so this is called addition and subtraction. The same case is applicable for subtraction case also. Here this delta x is always we are calculating the maximum possible error. Okay, maximum possible error. So this is called maximum possible error. This is called maximum possible error. Okay. Even for subtraction also we are using maximum possible error. So maximum possible error, we are doing it for subtraction. For example, if I'm doing x equal to a minus b, x equal to a minus b, and delta x will be equal to, it is not delta a minus b, it is even plus delta a plus b. This is not delta a minus b, do not confuse. Whenever minus coming, this is also plus. Error is also plus, because error we are calculating the maximum possible error condition, not the minimum error conditions. So error is always the maximum possible error condition. That's what we are applying addition rule, even if two quantities are subtracting. Now I can say x plus delta x. What is the value of x? A plus b. Sorry, a minus b. Value of a is x is a minus b. What's the value of delta x? Delta a plus delta b. So this point is important. Okay, that's what I've written. Addition and subtraction, common rules are applying. A minus b and delta a plus delta b. For a subtraction, for an addition, a plus b. Here, instead of x, what will come? A plus b. Instead of delta x plus or minus, what will come? Delta a plus delta b. So errors are always adding up. Are always adding up for a subtraction cases also and for additional cases also. Okay, errors are the maximum possible error. So error meaning is like we want to find out like maximum possible error conditions. Okay, so subtraction and addition under propagation of error topic is over. We'll move to the next topic. What is other mathematical basic algebraic operations are there? We know we have addition there, we have subtractions there, then we have other two operations, right? You know what are the things? Yes, it is multiplication and division. That's the second heading. Multiplication and division. Second one. Multiplication and division. Multiplication and division. For example, let me take a quantity. X will be equal to a into b. Okay, this is one case. Another case, y is equal to a by b. In both cases, we are going to handle how to find out this error cases. So here, delta x. Okay, in case of multiplication and in case of divisions, we will use something called differentiations property. Differentiation means change in value by original value. Delta x by x. What is called delta x? Delta x, you know, right? It's called absolute error? No, it's not absolute error, right? It's a mean value? No, it's not mean value. So what is called? This is called what? It is actually the mean absolute error. This is a value of mean absolute error. So this is called we know this is called mean absolute error, and this is called what? Called mean value. So whole together this term is called what? Fractional error. So this is our fractional error, or this is called a relative error. So which means in case of multiplication and division, we are going to find out the fractional error or relative error. This can be written as delta a plus delta b divided by b. It's always plus, it's not additions. Okay, now if somebody will ask us to find out the value for delta x, that is our aim. In case of division also, we will write delta y divided by y is equal to delta a divided by a plus, there is no minus, delta b divided by b. Even it is multiplication also, even if it is division also, it is plus, it's not minus. Okay, then I want to write the value of delta x. So my original value is x plus delta x, means the final result. Okay, so what is x? X, I know it is called AB. What is delta x from this one? Delta x means this x has to multiply towards right side, which means delta a divided by a plus delta b divided by b whole multiplied with x. And this is called x plus delta x. Similarly, for division also, how we will write the final result? Final result means a has contains error, b has contains error. So x value is x plus or minus delta x. X plus or minus delta x. Similarly, for y plus or minus delta y is the final result. Okay, so what is y? It is a by b plus or minus delta y divided by, not delta y, delta a, right? Delta a divided by a plus delta b divided by b into y, and this is the final representation of the error. So in case of multiplication and divisions, we have a slight difference with respect to addition and subtraction. In case of addition and subtraction, we are just adding the errors, but in case of multiplication divisions, to find out delta x, we are going the method of relative error or fractional error. Okay, so let me take an example so that it will be very clear. Okay, so we'll take one example. Hope you have written, else pause the video and write the things. Okay, so okay, so let's continue. We have a rectangle. The length of the rectangle is 2 plus or minus 0.1. Breadth of the rectangle is 1 plus or minus 0.1. Question is asking what is the area? What is the area? A is what? We need to find out A. So to find out A, final result, both will contain error. So my aim is I need to get A plus delta A. This what is my aim. What is A? Okay, so we know, first we'll write delta A divided by area will be equal to, okay, before going to that, we'll first finally write A will be, okay, let me start here. A will be equal to length into breadth. So delta A divided by A will be equal to delta L divided by L plus delta B divided by B. Okay, what is delta A? I don't know, I have to find it out. Okay, so delta A is equal to, what we can write as delta L divided by L plus delta B divided by B into length. Okay, so not length, it is called A, area here, right? From here delta A, delta L by L plus delta B by B, and this A is multiplying towards the right side, so I will get delta A. So I'm going to find out delta A is equal to, what is delta L? Delta L is the error value. What is a delta L? Delta L is called this 0.1. So 0.1 divided by L. L means its original value 2 plus delta B is how much? 0.1 whole divided, what is B? 1 into, what is A? A is given L into B. So this is L. This is actually, this is written as L plus delta L. This is written B plus delta B terms. Okay. Okay. So here A is equal to L into B. So L means 2. B means 1. So 2 into 1. We will write 2 into 1 to understand you easily. So this we can further solve. This is coming 1 by 20 plus 1 by 10 into 2. 2 I'm multiplying to inside. So what should I will get? 1 by 10 plus 1 by 5. I can simplify. 10 is LCM. So 1 plus 2, it is 3 by 10. So my final value is A plus or minus delta A, which is equal to, what is A? A means 2 into 1. So 2 plus, what is 3 by 10? 0.33, right? 0.33 plus or minus A. So this is the final error in the measurement of calculating the area of the rectangle. So here there are errors are present in length, 0.1 error, original value and error value. Similarly, B is original value and error value. We need to calculate the area. Area is also containing the combination of the error, or A is carrying the error, propagating the error from length and from breadth. So both is providing an error to length area. So the area error will be 0.33 and the true value of area is 2 and the error value in the area is 0.1. Let's see an example will be here. 0.1 is given error here. 0.1 is given error will be here. But how much error is coming at the end? 0.33. That's what I told the previous example as a ship example. If you are giving an area. Okay, if you have giving some area, some error, then if it is a minor error for you, when it is come to a system kind of design, for a whole system design, the impact will be higher. So be careful. This is one example of calculating a plus delta a for an example of a multiplication. Same case is applicable for a division also. So propagation of error for addition and subtraction, it's quite easy, just adding the errors. For in case of multiplication and divisions, we are actually finding the relative error and we are finding delta a from this formula. Okay, hope this is clear for you. This is the whole topics from error analysis. Okay, thank you.